So today's lesson is on trigonometry. Like I had mentioned, trigonometry is going to be new. So we're going to definitely slow down and take our time with it. It's kind of cool. And once you get it, it's not too tough, but it's going to seem weird at first. So our essential question for today is how can we use trig to find triangle side lengths? So sometimes I'll say trig instead of trigonometry. Trig is the shortcut for trigonometry. I've been using trigonometry for so long that I'll oftentimes just say trig. So when I say trig, it means it's a shorthand for trigonometry. Let's get started. All right, triangles like this have been impossible for us to solve in the past. We could solve other triangles with the Pythagorean theorem, but this one, we don't know. That's a 21-degree angle and a side of 10. This side, that x, we can find it, but the only way we can find it is by using something called trigonometry. And when we use trigonometry, we could find it's 27.9. So what we're going to learn today is we're going to learn what trigonometry is and how we can use it to find side lengths like that one. All right, so there are some basic terms you're going to need for trigonometry. In a right triangle, there's what's known as the opposite side, which I'm going to abbreviate with OPP, the adjacent side, which is ADJ for adjacent, and the hypotenuse, HYP. That's for right triangles. Now, in a right triangle, the hypotenuse should be a one we know. We might have heard of that before. Anybody know which side in a right triangle is the hypotenuse? All right, this side is the hypotenuse in a right triangle. So I'm going to write right down there. That's the hypotenuse. I'm just going to abbreviate it with HYP. The hypotenuse is always the longest side, and it's always the side across from the 90. If that's helpful for notes, you can put that in there. So the hypotenuse is the longest side. And it's across from the 90-degree angle. All right. When we talk about opposite side and adjacent side, that really depends on what angle we're looking at. So let's say we're looking at this angle. Let's say that's a 21-degree angle right here. If that's a 21-degree angle, I'm going to name one of these sides A and one of the, you know what, I'm not going to do A and B. I'm going to do L and M. I'm going to call that side L and that side M. Which side do you think is the opposite side? Is it this one here, L, or is it that one there, M? And why? Which one is opposite the 21-degree angle? Come on, we got to have somebody be able to guess this.
L.
L, yeah. So opposite means the far side. It's like across from you. So L would be the opposite side. So if I'm looking at this angle 21, that far side, that side that's opposite, that's going to be called the opposite side. The word and maybe I'll even put parentheses here. So opposite. Opposite would be across from the angle. That's the opposite side. The last side there, that's the adjacent side. Adjacent means next to. If I was adjacent to somebody, I'm standing next to them. So this side here, that's the one that's right next to the angle. So that would be the adjacent side. This is the opposite side. That's the adjacent side. Next to the angle. All right, to understand trigonometry, we have to understand which side is the hypotenuse, which side is the opposite side, and which side is the adjacent side. So I'm going to do a quick poll to see where we're feeling with that. Opposite, adjacent, and the hypotenuse. 1 through 5, yeah, I totally get which one's which. Is 1, it's easy, or 5, I don't know what you're talking about when you use those terms. Lots of 1s, 2s, and 3s. Great. Let's just check one and find out. So if I'm looking at angle A, so angle A is the one I care about right there. Which side is opposite angle A? Which is the opposite?
B.
So when you say B, you mean BC, that one right there?
Yeah.
You're exactly right. BC, that would be the opposite side. Which side is the adjacent side?
C.
Yep, AC. AC, that side right there, that's the adjacent side. And then the hypotenuse would be the longest side. That side right there, that's a hypotenuse. Perfect. So you got to be able to say opposite side. Opposite is opposite the angle you're looking at. Adjacent side is the one right next to the angle. And the hypotenuse is always across from the 90. It's your longest side. Good. All right. Now that we've got that, the last thing, this is where we're going to talk about sine, cosine, and tangent. And this is going to seem strange at first, but sine, cosine, and tangent are trigonometry terms, and they're just ratios. They're just fractions of two of those opposite, adjacent, and hypotenuse sides being divided by each other. So sine is spelled like this, S-I-N-E, but the abbreviation looks like this. So it looks like sin. We'll still pronounce it sine. Hold on. We're going to talk about this in a minute. That's sine, that's cosine, that's tangent. A lot of times students will call that sin and call that cos and call that tan. You can, which is fine, but they're abbreviations. They're abbreviations. So just like this, if I wrote this down, my name, that's my name. Miss Chi, would you say my name?
Mr. Anderson?
Yes. Nobody says Murr Anderson. They don't look at this, go, oh, that's an MR, that's Murr Anderson, because it's an abbreviation that stands for Mr., right? That there, you can say sin, but that's like saying Murr, like that's like saying Murr Anderson. That SIN is an abbreviation for sine. So when you see me read that, I'm going to read that as sine. If you say sin, I'll totally know what you're talking about. No worries, but just know it's an abbreviation for sine. So sine is the value you get when you take the opposite side divided by the hypotenuse. That's your sine. Cosine is the value you get when you take the adjacent side divided by the hypotenuse. And tangent is the value you get when you take the opposite side divided by the adjacent side. So what we do with trig is we take different sides and we divide them. So for example, if I gave you a triangle here, and I told you this side was 3, and that side was 4, and that side was 5, and I was looking at this angle right there, let's call that angle A, and I ask you guys, hey, what's the sine of angle A? Well, the sine of angle A would be the opposite side divided by the hypotenuse. What's the opposite side in this picture? What side is opposite from angle A?
4.
Yep. And the hypotenuse is
5.
5. Yep. So the sine of angle A would be 4/5. Or if we like that as a decimal, it'd be 0.8. That's what the sine of that angle is. And we're going to use that to help solve problems. But this is where it gets weird and new. It's like, that's kind of crazy stuff. So before we actually start using them to solve problems, we're just going to practice these different values, knowing that sine is opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over adjacent. This is where it gets new. So I'm going to ask 1 through 5 where you're feeding. And I'm okay with anything. 1 being, it's easy, I get it, to 5 being, you're talking crazy, Mr. Anderson. How do just these ratios feel? Like I could find the cosine of angle A and the tangent of angle A. I'm not sure why I'm doing it yet, but I get it. All right, lots of 3s, couple of 4s, couple of 2s. So even 1, 1, nice. So basically we're feeling we can do it. Maybe we don't understand why yet. That's the important part we're gonna get to. But let's just practice it. Hey, look at that. The same exact problem we came up with. Sine is opposite over hypotenuse. We just did this problem right there. What are the odds? Look at that. 3, 4. Oh, no, it's not quite the same. Look at the one I made up. Look at the one there. What's the difference?
2 sides are switched.
Yeah, I switched them. So let's answer this one. All right, if I use this triangle, anybody brave enough to tell me what the sine would be equal to? What over what? So the sine of angle A, this angle here. All right. If it's hard, what I like to do is I like to name all my angles. Like this one, opposite adjacent or hypotenuse. Which one is the 5?
Hypotenuse.
That's the hypotenuse. The 3, well, that's across from this angle. So that's my opposite side. Which means that 4, that must be my adjacent side. If you can name those 3, then it's easy. Sine is opposite over hypotenuse. Well, the opposite side is 3. The hypotenuse is 5. So opposite over hypotenuse would be 3 over 5.
3/5.
3/5. Exactly right. Cosine is the adjacent over hypotenuse. Anybody brave enough to unmute themselves and say what cosine is going to be in this particular case?
Four over 5.
Yeah, thank you. So cosine is the adjacent side, which is 4, over the hypotenuse, which is 5. 4 over 5. Thank you, new voice. That makes me happy. I am thrilled. Last one is tangent. What's tangent going to be equal to? What over what?
3 over 4.
Yep, tangent is the opposite side over the adjacent side. Opposite over adjacent. 3 over 4. All right, awesome. We are almost to the point where this actually becomes useful. I am going to keep asking 1 through 5 because this is important. Now that we did those 1 through 5, I get how to do that. You may not understand why it's important yet, but I get how you just got those 3/5, 4/5, and 3/4 numbers. I get that stuff. So 1, yep, I get it. I don't know why we're doing it, but I get it. 5 being, yeah, that was weird and hard. Nice, lots of 1s, lots of 3s. Good place to be. Okay, here's where it's going to start getting useful. So why do we care about this sine, cosine, and tangent stuff? And the answer is due to the hard work of a number of people who long since dead, a long time ago. We know the sine, the cosine, and the tangent of any given angle. And that can help us to find answers to our problems. So there are a couple of ways to find sines, cosine, and tangent. There is what's known as a trig table, which I will show you, or you can use your calculator. But we're going to actually jump straight into a problem. We're going to solve this problem here. Don't worry about this. This is something I actually often do in person, but we'll do that once we actually solve one. So let's look at this problem. This is where trig becomes useful. We're going to use trigonometry to find x. We're going to find out how long this side is, and we're going to use trig. So with trigonometry, it's always involving an angle. In this case, the angle I've got is 15 degrees. So to use trigonometry, we need to figure out if we should use sine, cosine, or tangent. And again, sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. Take a look at which sides we have there and which sides we want to find. Which one of these 3 might be a good match for this problem? Sine, cosine, or tangent? All right, let's name them then. I like naming these things. If I name this one, which side is that? Is that the opposite side, the adjacent side, or the hypotenuse?
Hypotenuse.
That's the hypotenuse. And which side is this one? The opposite side, the adjacent side, or the hypotenuse?
Adjacent.
Adjacent. All right, now let's look at our trig functions. Which one uses hypotenuse and adjacent?
Cos.
The cosine, exactly right. So the cosine is the one we're going to use. We're going to use cosine because we've got the adjacent side and the hypotenuse, and it's always of an angle. So it's a cosine of some angle. Well, in this case, the angle is 15. So the cosine of 15 degrees is equal to the adjacent side over the hypotenuse. The adjacent side is x, and the hypotenuse is 25. Once we do that, we can find out how long x is. The only thing that's holding us back is this cosine of 15 degrees. So I'm going to show you two ways to find that, and you can use whichever way you like. I'm going to ask you which way you prefer once I show you the two ways, because then that's how I'm going to keep doing it. So cosine of 15 degrees, it's just a number. Here's how we can find out what that number is. All right, in our trig folder, down here, I put a trig table for finding trig values without a calculator. If I click on that, there's going to be a table here. And it's going to have all of our different trig values. You can use this table to find any trig value you want. We were looking for the cosine of 15 degrees. So let's see here, cosine of 15 degrees. Here's degrees. I want 15 degrees. There's cosine. Cosine of 15 degrees, that's equal to 0.9659. So if you like using the table, you can just download that table and use it to find any sine, cosine, or tangent. In this case, cosine of 15 degrees is right there, 0.9659, and I can write 0.9659 in place of the cosine of 15 because that's what it's equal to. Does that make sense to people? Let's just double check this. I'm going to ask random ones before we finish our problem. If I ask for the sine of 10 degrees, what's the sine of 10 degrees?
0.1736.
Yeah. Sine of 10 degrees, 0.1736. It's right there. So you can feel free to use this table for finding the sine, cosine of or tangent of any angle. The other way you could do it is you could use a calculator. I'm going to go to Desmos.com because that's the calculator I like. But just about any calculator has a sine, cosine, and tangent function. The only tricky thing with calculators is you got to make sure you're in degrees. Some calculators are measured in radians, others are measured in degrees. But if I put the cosine of 15 degrees in here, there it is, 0.9659. Same thing as before. All right, so two ways to find sine or cosine. One way is just use your calculator. Plug it into the calculator, it works. Right, I could use my table to find things. I'm going to solve this problem, and then I'm going to ask which method people prefer, if they prefer the table or the calculator. All right, we are almost done. You guys have been doing awesome. This is new stuff, and I am really proud. You guys seem to be staying with me and doing it. All right. Okay, here's our original problem again. The cosine of 15 degrees, that was just a number, and we could look that number up using the table, or you could have plugged it into a calculator. That number was 0.9659. 0.9659. And that was equal to x over 25. Now it's really easy. If I don't want that 25 down here, how am I going to get rid of it so it's not down there anymore?
You multiply it?
Yep, multiply by 25. On the right side, I'll have x by itself. And on the left side, I just need to multiply those numbers, which I would probably use a calculator for. I don't want to multiply that in my head. So I've got a calculator here. 25 times 0.9659 is about 24.1. That's how long X is. X is 24.1. We were measured in centimeters before, so I might as well put that unit here. 24.1 centimeters. That's how long X is. All right. We just did our very first problem using trigonometry. There was a lot of build up to it, but that's it. Like that's trigonometry right there. That's how we do it. I am going to ask, because this was our first problem we've done, how easy or hard does it feel now that we've done a whole problem? So 1, that's actually not bad. I get it. 3, it's okay. Excuse me. It's okay. I get it all right. Or 5, that was really hard. All right, of the people that are voted, there were all 3s. We're feeling pretty good about it. There's a few people that didn't vote. I'm a little worried about you guys, whether you're finding it easy or hard, or you're there. There's another person voting, getting it okay. All right, good place to be. Lots of people saying they get it okay. I'm glad. Let's try at least one more, and then we'll do the homework. So at least one more. Take a look at this one. There's my 50. And again, I'm going to write my trig functions over here again. It's good to have these written off to the side somewhere so you remember them. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And today I think it's a worksheet. Is it a worksheet? No, we should. So you should. Yeah, I should definitely have these written down somewhere when you do your homework, because it's going to make it so much easier if you have these written down. So I'm just going to write them down right there on the side. All right, let's identify our sides. Which side is that one? Opposite, adjacent, or hypotenuse?
Adjacent.
Careful. It would be adjacent if this was my angle.
Oh. Sorry.
No, don't be sorry. That's why I've got this problem here. This problem is a trig problem. The angle's up there. So if the angle's up there, that side isn't next to that angle. Which side is it?
Cross.
Across from the angle.
It's
So it's the opposite side. Hold on, we got somebody who's just trying to join. I'm trying to let them in. Okay, here we go. So yeah, since that's across from the angle, that's the opposite side. So this is the opposite side because it's opposite that 50-degree angle. This X, that's right next to the angle. So which side, opposite, adjacent, or hypotenuse, stands for one that's next to the angle? That'd be adjacent. Adjacent means next to. So now that I know I'm looking at the opposite side and the adjacent side, which one of these trig functions am I going to want to use? Come on, I think you guys have got it. Which one? Sine, cosine, or tangent? Which one has the opposite and the adjacent?
neither.
Oh, no wonder there's such a long pause. I screwed up. I don't screw up too often, but I totally did this time. I wrote one of these wrong. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, I wrote opposite over hypotenuse, and I meant to write opposite over adjacent. No wonder. I was like, there's such a long pause. Why is this? That's me messing it up. Tangent is opposite over adjacent. I think I even said opposite over adjacent. I'll have to check the video, but I wrote hypotenuse instead of adjacent. So tangent is opposite over adjacent. So because I've got the opposite side and the adjacent side, we're going to use tangent. In this case, it's a tangent of an angle, tangent of 50 degrees, equals the opposite side over the adjacent side. The opposite side is right here, that's 22, over the adjacent side is right there, 22 over x. All right, we're gonna solve this and see how it's going. But first, before we solve it, I want to know how many people prefer to solve this using the table versus finding the tangent of 50 with a calculator. So I'm gonna do an A and a B. And I want, if you prefer the table to find the value of tangent of 50 with the table, I want you to choose A. And if you prefer using a calculator, I want you to put B. So you might not know yet, but what do you think? Would you prefer a table or a calculator to find that value? You can ignore the question. It says, do you want to try it yourself? But that's not what we're looking at. We're looking at table or calculator. So set A if you prefer the table, B if you prefer a calculator. If you don't care, then you don't have to vote. All right, most people are saying the table. If you like the table, that's just fine. You can use the table. Some people are saying the calculator. If you like a calculator, that's just fine. You can use a calculator. Since most people in this class said the table, that's how I'm gonna do it. So I'm looking for the tangent of 50 degrees, and I'm gonna use it with the table. So I'm gonna share that table again. So share screen, this one. Here was my trig table. So I'm looking for the tangent of 50 degrees. What is the tangent of 50 degrees using this table? Well, here's 50 degrees. Tangent's over there. Tangent of 50 is 1.1918. So that's what I'm going to put into for the tangent of 50, 1.1918.
How can you find it on a TI-84?
On a TI-84, you're going to want to make sure you're in degrees. So can you hit your mode button, Miss G?
Mode, yeah.
When you hit mode, do you see an option that says degrees or radians? It's DEG or RAD.
Yeah.
Okay. Which one is, so make sure you're selected to degrees. Are you selected to degrees?
I am now.
Okay, then if you go back, if you hit the tan button, it's in the middle of your calculator. That's for tangent. And you can do tangent of 50 and you should get the 1.1918.
Yeah. Yeah, because when I did it the first time without putting it in degrees.
Yeah, that's the only thing with, that's the only thing with calculators that's a little bit dangerous. You got to make sure your calculator's in degrees. And when I'm in person, I can always help people out like that with their calculator and make sure it's in degrees. But it's harder when I'm not in person to make sure it's in degrees. All right. So here we go. We said tangent of 50 was 1.1918. So I did that. But now I got to solve this one for x. And this is a weird one for x. Anybody know what's weird about solving this one? Why does that seem harder right now? What about that problem makes this problem look hard?
The X is on the bottom.
Yeah, the X is on the bottom. I don't like that. I don't like it when the X is in the bottom of the fraction. It's super annoying when that happens. So what we're gonna do first is we're gonna fix that. We're gonna I don't want that X down there. Right now that's 22 divided by X. So I'm gonna do the opposite. Instead of dividing by X, I'm gonna multiply both sides by X. Now on the left side, when I multiply by X, I'm gonna get 1.1918 times X. But on the right side, what nice thing is gonna happen to those X's?
They're gonna go away.
They're gonna go away. They're gonna cancel out. And then I get a 22 by itself, and then I don't have X on the bottom anymore. So if your X ever ends up in the bottom of a fraction, that's totally annoying. Just multiply both sides by X, and then it's not on the bottom anymore, and then it's a whole lot easier. Now, how do I get that X by itself? What do you gotta do to both sides?
divided by 1.1918.
Uh-huh. Divide by 1.1918. 1.1918. Those 1.1918s are going to cancel out. And we're going to get x by itself. And I am definitely not doing that division in my head. I'm going to do in the calculator 22 divided by 1.1918. I get 18.5 about. 18.5 centimeters. All right. I'm going to break this down and ask how easy or hard each of these parts was, so I can tell where we're at. So the first thing we did to solve this is we identified our adjacent side and our opposite side. We just named those sides. Easy to hard. How hard is it just naming the adjacent and opposite sides? Oops, that's a wrong poll. Let me ask again. So this is the last time we're doing polls, but I want to just check where we're all at. So easy to hard, just naming those sides, opposite, adjacent, and hypotenuse. How's that feeling? All right, lots and lots of threes. The second thing we did is we used those sides to figure out that we needed tangent, and then we wrote the tangent of our angle, the tangent of 50, equaled the adjacent over the hypotenuse side. So we set up that equation to solve it. So just the part of setting up this equation, how easy to hard does that part feel? I'm going to relaunch that poll for you. So setting up the equation, tangent of 50 equals 22 over x. All right, lots of threes for that. One or two fours, a little bit harder, good. Next part, we took that tangent of 50 right here, and we looked that number up in our table to rewrite that as 1.1918. How hard was that part of it? Just looking up that value. All right, 2s, 3s, and 4s. Good. Okay. Last thing then, overall, if I gave you a new problem, if I said, we're gonna get to that in a minute. If I just said, I'm gonna make one up. Here's a right triangle. I'm gonna call this 30 feet. I'm gonna call this X, and I'm gonna call that 15 degrees. If I asked you to solve that one by yourself and find X, how easy or hard do you think it would be to try that one on your own? All right, lots of threes, a couple of fours, a couple of fives, people feeling they get it okay. With those values, I don't think we're gonna do that one on our own. Instead, we're gonna start the homework together. So anybody who is here, we're gonna do 5 problems together, 11, 14, 15, 16, 17, just 5 problems. And we're gonna try these ones together instead of making you do another one. You guys, a lot of threes, I think you guys got this. So awesome, good job. I'm gonna stop the video and we're gonna start our homework.